My name is Schaefer, and in my overheads, there's absolutely nothing about myself. And I didn't understand the introduction. I'm working as a private consultant, and most of my time I'm either helping organizations who are in real trouble. Most of the time it has to do with testing or with quality issues. Some of my time I'm using with improvement processes with companies working. I'm working for a longer time. And I'm leading an organization called the Norwegian Testing Board. That's part of an international society. It's called ISTQB. There's a Polish testing board. And some of you are probably so-called certified testers. I'm one. And the organization I'm leading is doing the examinations in Norway. So, well, if you are a certified tester, don't think you are able to do good test. That's a different thing. It's a totally different issue. But anyway, I hope I can give you some value from this. Let's see. Testing. The idea is, does testing have any value? And I'm using a very broad definition of testing, the one we use in ISTQB. We say testing is both static and dynamic methods. It means running the program and see what happens, but it also means reading documents, analyzing the code, analyzing requirements, and all this in order to find anything that could be wrong. Well, if there's nothing, there will not be test. But if there's anything, you can critically or destructively read the stuff. And if there's anything you can execute, you may try to execute it. And again, do that in a critical way and hopefully find some problems before the customers find them. So this is the value of testing generally. If you do too much test, you waste resources because you will release too late and it's going to be too expensive. But I think very few of you are in that kind of business. You test too much. So I think most of you are probably in the other, in the downmost part, too little testing. And the worst about too little testing is not a product full of defects, but it's a product where you don't know the risk. You are thinking about, shall I release it? Shall I sell this? Or doesn't it work? Essentially, you want the customer back. You don't want the product back. Getting the product back, that's a risk. So you don't know anything about the risk. So testing is about getting information about the risk in the product. And information has a lot of value. If you look at that, the American government spends billions of dollars every year to support an organization called the NSA. If you ever heard about Edward Snowden, you know what the NSA is. They spend billions of dollars every year. Why? Because that organization provides some information the government appreciates as being valuable. And some of that is about risks. So there is a value. There's an economic value. And you have to find out something about the same in your own organization. So what you do, you test like the NSA. Yeah? If you're working in testing, you are the NSA of your organization. If the other thing is too many bugs survive. And then you get customer support calls, and you get a help desk, and you get a lot of bug fixing and new releases and a lot of extra cost. and you get a bad reputation. Bad reputation means your customer will try to find somebody else to buy the next product. You don't get you don't get the customer back. So the customer will go somewhere else. There's a problem about this. Sometimes the customer has no alternative. And then you may be in a good position for 10 or 20 years to come. But then maybe there's a revolution and you are not there anymore. Bad reputation. And there may be other damage to your company. For example, some of your key employees may leave the company because they don't want to work with bad quality anymore. There's another company, better organized, and your people want to spend their life working with better stuff. So, and definitely there might be more problems, but these I think are the main problems about too little testing. So you want to optimize how much you test. Not too much, not too little. So let's see if this works, where to push. I want to forward. Okay. You have a quantifiable and a qualitative way to express this. If you need to show value to your government, try to quantify things. If you can't quantify it, you still have the qualitative things mentioned down there. You have the quantifiable. How many bugs did you prevent from reaching the customer? You may actually count the major and critical bugs you fix during the test execution phase and count how much value is that in preventing help desk calls, support calls, and bad reputation in the market. So you prevent some must-fix bugs. A not must-fix bug is something you include in a bug list, for example. That's the second one, bug information. Other bugs included in README files or whatever. These the known bugs. But that is stuff the customer may exist with. And if customers know some bugs, they can exist with them because they know the risks and maybe they know the workarounds, and you can include them for a time. Risk is better known, I told you before, and risk can be quantified. There is a risk is defined as probability times impact. You may quantify that. You can fix bugs and reduce the risk to a level where you can exist with it. And finally, you get information about quality and in general. And qualitative, reputation, and less surprise, and so on. So let's see. I got, a month ago or so, I got something called the Hewlett-Packard World Software Quality Report. It's on the web. If you Google for it, you will find it. And I just got this sentence out of it, put in here. They say user tolerance for application errors and so on, or inconsistent experience and so on, requiring organizations to pay even greater attention to quality and reliability. And there's a little bit more. So they found generally in industry and IT industry, the tolerance for bad quality is going down. So we have to do things in a certain way better. And they found in 2012, on a worldwide scale, organizations use 12% of their resources for quality-related issues. Quality, system testing, acceptance testing, reviews, prevention. That doesn't seem to be much. For some of you are probably using a lot more, but some of you not. And in 2014, they said it's 18%, so it's definitely increasing. And their projection for 2017 is 26%. I hope this is not going up to 100% in a few years, because that wouldn't be sustainable. But think about this, about 1/5 of your resources are probably going into testing and prevention-related areas. This does not include the cost to fix any bugs and clean up the mess. That's called the waste cost, and it's outside of that. This is the cost for reviewing, testing, training, prevention, measurement, and all the stuff we are talking about, not the cleaning up. So it's growing. The importance of that is growing. World Quality Report is called. You can download it. But they also describe a few trends. And one of the trends is faster tests. What means faster tests? In most cases, it means faster test execution. And that means test automation. And if you look at agile projects, there were a lot of talk about agile. Maybe you use that. If you have 2 weeks or 4 weeks to do a release, you don't have time to do 4 weeks of testing. You have time, something like 10 minutes of testing. And the only way to get that is by automating tests. Where to get the trends? Well, companies like Microsoft and Google were mentioned. If you look at testing at Google, they published a book about this. You will see they are running hundreds of millions of test cases within less than 1 hour. Very strange, but it can be done because they run it on thousands of servers. And essentially, it's no problem to get thousands of virtual servers. Google sells them, or Amazon, or whatever. Maybe you have your own servers. But what they do, they run enormous amounts of testing in very, very short time, but that is fully automated. And the idea they have is whenever you, if you're a developer, whenever you check in anything you did, you run all the tests again. And the general answer time for testing is 5 minutes for the more local tests, and about 1 hour for the more remote tests, and for the very remote tests, 1 weekend. Well, the only way to do this is by automating tests. That's a trend, and especially has to do with agile development. And then include security, performance, and usability. These are the ilities. Until even now, but at least until a short time ago, companies were only addressing functionality. Does it work at all? But for a software product, it's not good enough that it works at all. There must be security, it must be fast enough, there must be reliability, and there must probably be a few more ilities, qualities, or characteristics or attributes, call it what you want. But you need that. So testing is not just about does it work or not, it's also about how well it works. So include performance tests, for example, very important. Okay. Now we have the cost of quality, and yesterday you saw a much better overhead than mine, because this is exactly the same as you heard yesterday with the Richard Taylor telling you. Cost of quality, and the word is wrong. It's not the cost of quality, it's the cost of non-quality we are thinking about in most cases. There are these 4 areas. It's prevention, it's detection, and it's waste, internal waste and external waste. You heard that. So what is prevention? Yeah, you organize the project. You do it systematically. You plan it. Yeah, upfront planning is part of that. Systematic work. You have some methods in place. You have some processes in place. That's systematic work. Train your people. Heard about the 3 Ps? People, process. Yeah, 2 of them are here. You have the root cause analysis. That at least helps you for the small and the medium breakthroughs. I'm sorry, it's not good enough for the big breakthroughs, but there you have your run methods. So this is cost of prevention. And there's prototyping. And by the way, part of prevention is actually using agile or incremental development. If you have trouble meeting requirements and finding out about requirements, then introducing agile methods is part of prevention. Then you have the cost of detection, and that is what my business is about. It's reviewing things, it's static analysis, automatic analysis of things, and it's testing, test design and test execution. And maybe many of you work in that. And then we have the cost of internal failure, and that is everything you pay because you find problems before the customer finds them. You read a document, you find some trouble, you fix the document, you reread it, you fix it once more. Now that's internal waste. Or if you do testing, yeah, you find a bug, you try to isolate it, you fix it, you retest, you regression test. You find another bug because the fix was wrong, you fix it again, and so on. And maybe there's delayed release. It takes longer time, so you can't release when you want. It's all of this. Probably the list is not complete. It couldn't be, because then I would need too small writing on this overhead. And then you have the cost of external failure, and that is any bug the customers find. And then things turn horrible. Yeah, you have the help desk and the user support, and maybe the customers have destroyed some of their data and have to clean up. And maybe you not only have to distribute the bug fix to one customer, but to many of them. So there may be a lot more. Typically, the external waste is a lot more expensive than the internal waste. So again, my list is not complete. But these are the costs. And now, how to compute economic value. The idea is you do more prevention, or you do more detection, or both. Now, this depends on which kind of work you are in. If you are into quality assurance or quality management, then probably you are into increasing prevention. If you are in testing, you are into increasing detection. And then what you get, sadly, you get more internal waste, because you find more problems, especially if you implement better testing, better reviews, better inspections, static analysis and testing. You find more bugs and you fix more bugs, so the internal waste cost goes up. And that's a horrible thing. You think you improve your test, and then you get even more internal waste, and you get even less popular than you have been. So that's the sad status. On the other side, you have the external waste, and hopefully you reduce that so much that the first 2 parts on this overhead will be cheaper than the last. And that's the idea. improve in order to get less external waste. Okay. Now, I'm using one source. I'm using several sources, but the main source I used for this was from Capers-Jones. He's an American and has collected data about how they ran projects since the middle of the 70s until now. So he has collected data about 13,000 different projects all over the world from different organizations, and then put that into a regression analysis and made a model from it, trying to find out averages and trying to find out rules about what is actually going on in software projects. And he found that there is a certain bug potential depending on how big your project is. And the idea how to measure how much software you do, he uses function points. So I have a big problem explaining to you what a function point is. But it's a concept. It resembles how you measure how much house you have. Yeah, if you want to tell me how much is your house, then you probably don't tell me how many bricks your house is built of. But you tell me something like how many square meters do you have, or how many sleeping rooms do you have, or something like that. So function point is a concept like the square meters of house or the number of rooms in a house. So it's not the bricks. Counting the bricks would be another popular measure. It's the number of code lines delivered. Some organizations count that, but it leads astray because there are small bricks and big bricks, and there's COBOL, and there's C++, and there's Java, and they all work differently. But counting the square meters of a house or the function points probably gives you better value. So he's using function points, and then the number of bugs you get, the bug potential, is the number of function points to a certain power. It goes exponential. So if you have small projects, you don't have any bugs. But if you have bigger projects, you have even more bugs. It goes exponentially up. The factor is not very much. The factor is something between 1.1 and 1.3. I'll show you on the other pages how big the differences are. But he found that depending on certain methods, you have a different bug potential. And he looked at different organizations, and here are part of these things. CMMI, you probably heard of, Capability Maturity Model. Organizations get a level from 1 to 5. 5 means very well organized, and 1 means relatively chaotic. He even has a level 0, which means definitely chaotic. And you see for 5, the power is 1.18. And for 0, the power is 1.24. Doesn't seem to make much of a difference. But if you have something like 5,000 function points, it definitely makes a big difference. And then there is mentioned the XP is on the second line. XP means extreme programming. It's one of the agile methods. It's strange. It gives you 1.19. Not bad. Yeah, and then there's RUP, Rational Unified Process. Yeah, that's not agile. It's a little bit old, but it's relatively well organized. Gives you 1.19. There's Scrum. If you really do Scrum, not if you call it what you do, you call it Scrum, but you actually do chaos. That's a different thing. Then you're down to agile, the average of agile. Agile means not actually agile, but it means you tell somebody we are agile, but in practice you are just on paper. Then it's 120, and then you have waterfall, the good old waterfall model, 122. Doesn't seem to be bad. But if you look at the right-hand column, 10,000 function points. Now, to give you an idea what that is, you probably are using a product like Microsoft Office. That's about 10,000 function points. And you find the uppermost CMM level 5, you get 52,000 bugs. Think about that, 52,000 bugs with a horribly well-organized company. Now, you probably are not at that, but you still have 50,000 bugs, and you want to find and remove them before the customer finds them. That's a lot. On the other hand, if you do one of the bad methods, you're down below, and you look on the right lowest corner, you have 91,000 bugs for the same project. So this is your possibility. You can go for 90,000 bugs, or you can go for 50,000 bugs. And the question is how to get the lower numbers. And the answer is by organizing your project better. The trouble is there's no economy of testing, but there's economy of prevention. This is mostly about prevention. So let's see more. He also checked what about different prevention methods, how much of the bugs do they reduce. So you get less. And he found, okay, formal inspections give you 60% reduction in bugs. How that? Well, the thing is, if people read documents in a systematic way, and they do that for a long time, they finally learn what kind of bugs occur, and then they somehow automatically learn not to do these bugs. And that reduces bug potential by about 60%. However, to get this takes 2 years at least. Now, for 2 years, you read documents and read them and read them and read them and find bugs and fix bugs and improve your checklists. And then finally, somehow people work in a different way and you don't do the same bugs as before. 60% inspections. And it's interesting, inspection basically means someone else is looking at your documents in a systematic and thorough way, aided by a checklist. And if you really think about it, everybody could do that if you only want to and you spend enough time. The trouble is you have to want it and you have to spend enough time. Otherwise, it doesn't work. There are a few others. Quality function deployment is mostly known in Japan. Has to do with designing things for quality, high level. Functional prototyping means first make prototypes in order to find out about requirements. Gives you 52%. Automated risk analysis. That has mostly to do with analyzing code and design and finding horrible areas that will give you trouble afterwards when things are deployed. So in order, instead of deploying the bad areas, you clean them up before you deploy them. Gives you 48%. PSP, personal software process, and team software process. You can read about that in books written by Watts Humphrey. Static analysis of code. There's a lot of tools, and all of you have tools like that. Your developers have that. They just have to run static analysis, instead of ignoring it. Root cause analysis, you heard about things like that. The last one you see, test-driven development, that is very old. It's from the 1970s and says, first you design your test and then you design the code afterwards. The first article about this I read was written in 1972 by Glenford Myers from IBM. He said, it's a good idea. First you make your test, and then you make your software afterwards, because making the test gives you the opportunity to think about what could go wrong. And then you make the code so it doesn't go wrong. So that's old. But you also have the opposite way. You can actually increase the level of bug potential, for example, by one, and the last line, by the good enough paradigm. Oh, it's good enough, so let's ship it. Anyway, my summary of it is vertical. Get involved early. Has very much to do with that. Be there early. So this is prevention. Then you have the next, and testing actually is two things. You can do things before you dynamically test, and most of that is review and analysis. And then finally you can test. And the test execution cost, this is bad writing. It's not testing cost and testing, it's test execution cost. They are directly related to the pre-test. Because if you have less bugs, then testing goes faster. If you have a lot of bugs, you have all this repeating again and again and again. So you increase how fast testing will go. And carelessness you will see in dynamic testing. Okay, this horribly to read. I don't want you to read the numbers. This is the potential for small projects, 1,000 function points. That's a little application. Think about Microsoft Office, 10,000, well, that's big. It's much smaller than Office. Yeah, some small product, your company website, maybe it's 1,000 function points. And then Capers-Jones put in the bug potential in the first line and said, okay, there's 750 requirements, defects, and 1,000 design, and 1,700 code, and 650 document. So total defects is 4,000, about 4,000 of them. How to get rid of them? He looked at different methods, typical methods, and they are on the left-hand side. You can do something like called desk check. Very strange thing, but that basically means if you write anything, you put it away for an hour or so, and then you read it again, and then you press the send button. You know, the send button for emails. You write an email, put it away for an hour, then you read it again and correct it, and then you press the send button. That's desk checking. It's easy. You can do that if you want to. Then it's Scrum. Then there's something called the customer review. You explicitly get the customers in to review stuff. Peer reviews, you get a colleague to look at what you have. Static analysis, mostly using code, automatic code analysis. And then you have the total removed down there. And okay, I give you the summary 2 days later. Small projects can remove 75% by these easy methods. It's 75%. But large projects may remove 90%. And going back, this is for a large project, 10,000 function points. That's Microsoft Office. And what you do, desk check, customer review, requirements inspections. Oh yeah, looking at the requirements, a little more than normal. Architecture inspection, design inspection. There's a lot of inspections. Yeah, that's not just reviewing. That is reviewing the hard way. But then it's static analysis and code inspection, and you get, okay, about 90% out of them. But if you looked at the total bug potential, I think you started by 50 or 60,000, and 90% of that, you still have 6,000 bugs for dynamic testing. But anyway, this is impressive. If you don't do anything of that, you get the full 100% into testing. And that's not very nice, because then you get too much debugging. Now, this is a summary of what happens then. You want to do dynamic testing. That means executing test cases and look at things. And Cambridge-Jones looked at how many percent of the bugs you find. And the bad news with this is there's no 100%. Actually, a lot of these numbers are rather near 50%. If you look at that subroutine testing, that's very low-level testing, typically done by developers, 60%. So if you have 100 bugs, 40 of them go to later test. And then you have system testing, 55%. So some organizations tell me, oh yeah, we have very good system testing. And then I say, okay, how many bugs you find? Yeah, we found 800 bugs and we fixed them all. And then I ask, how many bugs do you think the customer will find in their acceptance test plus the first year of use? And they say, oh, not many. But if they told me 800, I compute, okay, it's 55%. So 45% are left, that's about 600. And the customer first year of use and acceptance test is about 80% of that. So customer will find something like 500 bugs. And these people are horrified, but that is industry average. If your numbers are better, please show me your numbers. That's the thing. Otherwise, I use Cambridge-Jones numbers. If you don't love them, don't use them, but then you have to have your own numbers, because they could be better, but they could be worse. 55%, unit testing 50, and so on. You have one that's interesting. Automated virus and spyware test, 80%. I have no idea how he got these numbers, but that's impressive, 80%. And then external beta testing, 40%. It's not acceptance test, 30%. Not very nice. So the basic rule for testing is you find half of the bugs and the other half goes to later testing or the customer. So testing is essentially like a filter. If you have many bugs in, you get many bugs out. If you have few bugs in, you get few bugs out. The value of testing is not so much removing bugs. It's very much about measuring the quality, measuring the risk, as I told you on the first page. So how much time I have left?
Not much, actually.
Not much. Ah, okay, good. I didn't see that. US average, you see in the middle, is 85% in testing. Don't think you are very much better. But there are companies that find 99%. Okay? It's in generally not the answer, but maybe pre-test is the answer. Summary, yeah, not very good. Far below 100. Yeah, you are not at 99%. I don't think so. So use defect prevention and use reviews, static analysis, desk checking, and all this stuff. That is much more important. Or you have to accept a lot of bugs. Let the customers find them, lose your reputation. And this one, I'm sorry, I don't have time, because now this turned red. If you want to, there is a little more, and there are references more. It's not just Cambridge-Jones, there are other references. Most of them are horrible. Bugs cost a lot. Okay, thank you.